All right, so we have already covered trig with sum of angles, difference of angles, and from there we talked about the double angle, which is really just double whatever angle you have, right? So angle of A plus A, which gives you 2A. So that's really the same thing. It's a very simple proof if you already know the sum and difference of angles. Now half angles does get a little bit trickier. It's a little bit different. In fact, if you take a look at your equations or formulas, there's plus or minus for all of them. So it is important for us to first think about, and this is not just like, okay, let me plug it in, plus or minus, and I get two answers. That's not true. You are going to get one answer. Okay, it's either positive or negative, and you have to make that determination. Okay, so in order to do that, I'm going to first talk about, okay, well, where the heck did my angles go, right? So I'm going to kind of look at the extremes, and I'm going to be looking at the quadrantials because I have four different quadrants: quadrants 1, 2, 3, and 4. And if I just look at the extremes of each quadrant, right? So quadrant one, that I'm never. It's my quadrantial at 0 and pi/2 are not part of quadrant one. But if I take a look at where those numbers are, um, then my theta/2 must fall between them as well. Okay, so let me say that one more time. If I look at the extremes of each quadrant, so for example, quadrant one, the most extreme value I can have is 0. The most extreme number that's still in quadrant one is pi/2 or 90 degrees, right? Then that whatever that angle measurement is divided by 2 must be between these two divided by 2, right? So that's my strategy by to look at, okay, where do my angles end up? Okay, so let's first take a look at quadrant one. So in quadrant one, I have these two values. I have 0 degrees and I have 90 degrees, right? So 0 divided by 2 is still equal to 0. 90 divided by 2 is equal to 45 degrees. Meaning, if my angle is within quadrant one, then even if I took the angle and divided by 2, it's still going to be in quadrant one because 0 is the lower bound of quadrant one. 45 is straight up in quadrant one, right? So that's that's fine. That's not a big deal. That's actually very good. Now let's take a look at my second quadrant. Again, my second quadrant, I have two extremes as well, right? I have an extreme here. This is the lower end of my quadrant two. My upper extreme, my upper limit essentially of my quadrant two is at 180 degrees or pi. Well, 180 divided by 2 is 90. 90 divided by 2, where you said this is in the first quadrant. So I have, in fact, you can kind of already see, hopefully see a pattern here. Um, if I have anything in the first quadrant, if I divide that by 2, it ends up in this range, right? 0 to 45. This is if my theta was in quadrant 1. My theta would be in quadrant 1 still. Theta over 2 would still be in quadrant 2. Um, but if my theta was in quadrant 2, I still end up in quadrant 1. At least my theta over 2, right? That's this range right here. So whether I'm in quadrant 1 or quadrant 2, they will both end up in quadrant 1. So I'm guessing at this point you can probably figure out, what if I start with quadrant 3? What if I start with quadrant 4? But let's just take a look at those values anyway, real quick, right? So again, I have 180. This is my lower bound for my third quadrant. My upper bound is going to be 270 degrees, right? Again, this divided by 2 is 135. This divided by 2 is 90 degrees. So my lower bound is, again, 90 degrees up here. But again, that's never going to happen because or I shouldn't say never, but I'm usually not going to look at my quadrantials. While my other bound, my upper bound at 270, when I divide that value by 2, that ends up 135, which is this guy here. So that shows me, actually, you know what, I'm going to draw that in orange. So that tells me if I have an angle that begins in quadrant three, I'm going to end up in quadrant two. And the value that I'm gonna get is going to be between 90 and 135, or as we've been using radians, I just use our the degrees because it's easier to do math that way. I think. Well, it's numerics, and I think we're probably more used to that. But it's going to be between pi over two and 3 pi over 4, or 135 degrees. So you can probably guess that if my angle started off in quadrant 4, it's also going to end up in quadrant 2. And we can show that because, again, 270, if I divide this by 2, this is 135. This is all the way around 360. If I divide this by 2, I get 180, right? So that's this category or this range right here. So indeed, if we start in quadrant 4, we end up in quadrant 2. So if I start in 3 or 4, I end in quadrant 2 for theta over 2. If my theta is in quadrant 1 or 2, I end up in quadrant 1 for, again, theta over 2. And again, the reason why this is important, let's take a look at an example and see how this kind of comes into play. I know that the cosine of theta in this question is 2/3, and they tell me theta is in quadrant 4. All right, so theta is in quadrant 4. Now, this just means in. Now, according to what we just did, I know then theta over 2 must be in quadrant 2. Along with what I know about all students take classes, and since I'm looking at cosine, I know that I need to choose the negative square root because I'm in quadrant 2. Now, this is the part that's tricky because a lot of people say, wait, I thought we were in quadrant 4. Isn't theta in quadrant 4? That's true, but I'm not looking at theta. I'm looking at theta over 2. I'm looking at the half angle, not the angle itself, but whatever angle that I used to have, I'm dividing it by 2. So you have to be very, very careful. And theta over 2 is in quadrant 2, not quadrant 4. Okay, so I want the negative version because I'm in quadrant 2 for cosine. All I'm going to do is just copy 1 plus cosine. I'm going to use theta here because that's what I have in the problem, all over 2. And at this point, I know what cosine is equal to because they give it to me here. Right? So that's 1 plus 2/3. That's all over 2. And all I'm going to do here is just simplify all the way. So once I've simplified everything, my final answer is negative root 5 over 6. So I know that like the whole lesson in the beginning, that all this is just for this negative sign, but obviously that's a huge deal. Positive uh, root 5 over 6 is very different than negative root 5 over 6. Now this in your packet is going to be already kind of written out, right? Because um, it's on the same page. I'm just going to write this real quick just as a quick reminder for myself. That means theta over 2. This is in quadrant 2. And again, if I use all students take calculus, in quadrant 2, my sign is positive. So I'm going to choose the positive version. In fact, because every single one of these goes to quadrant 1 or 2, at least for us, because we don't really go beyond 360, we're always going to be in the positive sign. So I'm going to just, again, rewrite this using the positive version here. This is equal to, for now, I'll write the positive just to show that I'm actively choosing the positive version. But from here on out, I'm not going to write it out. 1 minus 2/3, because that's, again, given to me here, over 2. So that's root 1/3 over 2, which reduces to 1 over root 6. Okay, because the square root of 1 is just 1. Now, this next question, I am told cosine is negative. So is sine. So that tells me my theta is in, well, again, let's take a look. All students take classes. Where is sine and cosine negative? That's going to be in quadrant 3, meaning theta over 2 is going to be in quadrant 2. Again, because I'm in quadrant 2, right, this should be theta over 2, not x over 2. I need the negative version. So that's 1 plus cosine theta all over 2. Cosine theta is negative 1/8. So 1 plus negative 1/8 all over 2. This is equal to 7 over 8 over 2. It's negative root, oh geez, root 7 over 16, which is negative root 7 over 4. So I'm going kind of quick with the calculations here, with simplifying, but I'm trusting that you can find common denominators, you can divide your fractions, and find the square root of 16. Okay, again, you have the same exact values here for theta. Theta is again in quadrant 3, so meaning your theta over 2 is in quadrant 2. Again, we're using sine according to all students take calculus. Sine is going to be positive, so nothing to worry about there for sine. I am going to choose the positive version of 1 minus cosine theta. This should be theta over 2. Again, I know my value, 1 minus 1/8, negative 1/8, all over 2. So this is 9 over 8ths over 2, which is 9 over 16, and this can be reduced to 3/4. Like I said, we're not going to look at tangent, so I wouldn't worry about that. However, just FYI, tangent of theta over 2, we talked about if you use tan of 2 theta, you can switch it to sine over cosine. You can do the same thing here. So I could do sine of theta over 2 divided by cosine of theta over 2, which you can just use our previous two numbers to figure out what that would be. Okay. If you want to use this, you may, but again, just make sure to figure out your sign for that. Okay. Now, this is a little bit different than what we did before because now I have pi over 12. Now, what we did before was say, well, we can find this by taking cosine of pi over, or 4 pi over 12 minus 3 pi over 12, right? We made this into a difference of angles instead. So that pi over 3 minus pi over 4. And then we said, okay, I know the difference is going to be cosine of pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. That's what we used to do. We can also do this by using the half angle identity. What I need to do then is to figure out, okay, well, pi over 12 has to equal to theta over 2. If I multiply both sides by 2, that means theta is equal to pi over 6. So, whoops. So I can rewrite my question like so. Because I want to write it in the form of theta over 2. Theta is pi over 6, so I can say cosine then is, cosine of pi over 12 is the same thing as pi over 6 over 2. Now, this is in quadrant 1, so pi over 12 is also in quadrant 1. So I'm going to rewrite this equals the positive version of 1 plus cosine theta all over 2. But cosine theta, theta is pi over 6. So I'm going to replace that. 1 plus cosine of pi over 6 over 2. I know what the cosine of pi over 6 is, which is root 3 over 2 all over 2. And it is okay to leave it as such. If you know how to combine that to make it look a little bit nicer, feel free to do so. You're not required. Next example, we're going to do the exact same thing. 5 pi over 6 is equal to some theta over 2. If I multiply both sides by 2, I get 5 pi over 3 is equal to my theta. So I can rewrite this as cosine of 5 pi over 3 over 2. Okay? Now, here you don't necessarily need to say, oh, this is in quadrant 4, therefore this is in quadrant 2. You know 5 pi over 6. Actually, you can actually do this without doing this, but this is just for practice. You know this is in quadrant 2. 5 pi over 6 is in quadrant 2, right? So you actually don't need to do that whole, oh, this is in quadrant 4, therefore this is in quadrant 2, and so on and so forth. Again, this is just for practice, so make sure you know how to do this. This is then negative, right? Because I'm in quadrant 2. 5 pi over 6 in quadrant 2. This is 1 plus cosine theta over 2, which is 1 plus cosine of 5 pi over 3. So that's equal to negative square root 1 plus 1 half. And that's equal to the negative 3 halves. 3 halves over 2, which is the same thing as negative root 3 over 2. Sorry, root 3 over 2, which you know this is true. You know that cosine of 5 pi over 6 is negative root 3 over 2, so that does work out. Okay, with last couple of questions here. Now, this one is a little bit tricky because now I'm working with negative pi over 12. Negative pi over 12 is here, right? I don't know why I did dotted lines, but it is going to be in the fourth quadrant. But this is one of the cases where, well, half of that is actually, oh, I'm sorry. If I want negative pi over 12 to equal to some theta over 2, if I multiply both sides by 2, I get theta is equal to negative pi over 6. So this is still in quadrant 4. So we have to be careful here because of this negative value. Okay, so we're actually in quadrant 4 for both. So if this is pi over 12, then this is pi over 6. Right, because it's half that angle measurement. So I can rewrite this as the cosine of negative pi over 6 over 2. Now I'm in quadrant 4, meaning I need the positive version here instead. So this is equal to positive 1 plus cosine theta over 2. But I know what theta is. That's cosine of negative pi over 6. Wow. So that is going to simplify down to 1 plus fourth quadrant cosine of pi over 6 is root 3 over 2 all over 2. And you can leave it as such. That's fine. Not very pretty, but that's okay. The last example I have, using the half angle identity, 7 pi over 6. Again, 7 pi over 6. Let's use a different color here. 7 pi over 6. I'm sorry, over 12. We want it to equal some theta over 2. I multiply 2 on both sides. I'm going to get 7 pi over 6 is equal to theta. Okay, so I can rewrite my equation as sine of 7 pi over 6 over 2. Again, you don't necessarily need to say, oh, okay, this 7 pi over 6, this is in the third quadrant, therefore we're back in the second quadrant. This is also in the second quadrant, right? This is in the second quadrant. Because 6 pi over 12 would be my quadrantial, that's pi over 2. 7 pi over 12 would be slightly more than that. Sorry, did I say 6 pi over 12? 6 pi over 12 would be pi over 2, right? So slightly more than that, I'm in quadrant 2. So therefore, it is positive. This is equal to the positive version of 1 minus cosine theta all over 2. And again, I know what cosine is. 1 minus cosine of 7 pi over 6. Cosine of 7 pi over 6 is again root 3 over 2. That's all over 2. Therefore, answer is such. And that's it. I hope this makes sense. I really tried to kind of talk through each problem in detail. If anything does not make sense, please let me know. Please come in for help. I'd be more than happy to go over with you.